Feature selection techniques in machine learning. AI intermediate level. Introduction. In machine learning, datasets often contain many input features. However, not all features contribute useful information to the model. Some features may be irrelevant, redundant, noisy. Including unnecessary features can cause problems such as lower model accuracy, longer training time, overfitting. To solve this problem, machine learning uses feature selection techniques. Feature selection identifies the most important features that improve model performance. This process is widely used in applications such as medical diagnosis models, financial risk prediction, fraud detection systems, recommendation engines, customer behavior analysis. Understanding feature selection helps learners build more efficient and accurate machine learning models. What is feature selection? Feature selection is the process of selecting the most relevant features from a dataset for training machine learning models. In simple words, feature selection equals choosing the most useful input features. Example concept. Large feature set means select important features means improved model. The goal is to remove unnecessary features while keeping the most informative ones. Why feature selection is important? Using too many features can create several problems. Example concept. Too many features means complex model means poor performance. Feature selection helps improve model accuracy, reduce overfitting, reduce training time, simplify models, improve interpretability. This makes machine learning models faster and more reliable. Feature selection versus feature engineering. These two concepts are related but different. Technique purpose. Feature engineering create new features from existing data. Feature selection choose the most useful features. Example concept. Feature engineering means create features. Feature selection means choose best features. Both techniques help improve machine learning models. Types of feature selection techniques. Feature selection methods are usually divided into three main categories: filter methods, wrapper methods, embedded methods. Each technique selects features using different strategies. Filter methods. Filter methods evaluate features based on statistical relationships with the target variable. These methods are fast and simple. Common techniques include correlation analysis, chi-square test, mutual information. Example concept. Statistical test means rank features means select best ones. Filter methods are often used in early stages of preprocessing. Correlation-based feature selection. Correlation measures how strongly a feature is related to the target variable. Example concept. High correlation means important feature. Features with strong correlation to the target are usually more useful. However, highly correlated features with each other may be redundant. Chi-square test. The chi-square test is commonly used for categorical features. It measures how strongly a feature is associated with the target variable. Example concept. Categorical feature means chi-square test means importance score. Higher scores indicate stronger relationships. Wrapper methods. Wrapper methods evaluate feature subsets by training machine learning models repeatedly. Example concept. Feature subset means train model means evaluate performance. These methods are more accurate but computationally expensive. Common wrapper techniques include forward selection, backward elimination, recursive feature elimination, RFE. Forward selection. Forward selection starts with no features and adds features one by one. Example concept. Start empty means add best feature means repeat. Features are added until model performance stops improving. Backward elimination. Backward elimination starts with all features and removes the least useful ones. Example concept. All features means remove weakest feature means repeat. This process continues until only important features remain. Recursive feature elimination, RFE. RFE repeatedly trains a model and removes the least important features. Example concept. Train model means rank features means remove weakest. RFE is widely used with algorithms such as SVM and linear regression. Embedded methods. Embedded methods perform feature selection during model training. These methods combine feature selection with the learning algorithm. Example concept. Model training means automatic feature selection. Examples include lasso regression, L1 regularization, decision tree feature importance, random forest feature importance, tree-based feature importance. Tree-based models automatically measure feature importance. Example concept. Decision tree splits means determine important features. Algorithms such as random forest, gradient boosting, XGBoost, provide feature importance scores. Feature selection workflow. Feature selection is usually applied during data preprocessing. Example workflow. Raw dataset, down pointing arrow, data cleaning, down pointing arrow, feature engineering, down pointing arrow, feature selection, down pointing arrow, train machine learning model. Selecting the right features improves model efficiency. Example Python code. Feature selection can be implemented using scikit-learn. Example using select k-best. From sklearn. Feature_selection import select k-best. Example using RFE. From sklearn. Feature_selection import RFE. Example using tree-based feature importance. From sklearn. Ensemble import random forest classifier. These tools help automate feature selection in machine learning pipelines. Advantages of feature selection. Feature selection provides many benefits. Advantages include improved model accuracy, reduced overfitting, faster training time, simplified models, better interpretability. Example concept. Important features means simpler and stronger model. This is especially important for high-dimensional datasets. Real-world applications. Feature selection is widely used in AI systems. Healthcare. Selecting important medical indicators for disease prediction. Finance. Selecting financial indicators for credit risk models. Marketing. Selecting customer attributes for behavior prediction. E-commerce. Selecting product features for recommendation systems. Bioinformatics. Selecting relevant genes for disease classification. Concepts learned from feature selection. Understanding feature selection helps learners understand. Checkmark how to reduce unnecessary features. Checkmark how to improve machine learning model efficiency. Checkmark how statistical tests identify useful features. Checkmark how algorithms measure feature importance. Checkmark how preprocessing improves machine learning pipelines. Feature selection is an essential step in building efficient machine learning models. Simple definition. Feature selection. The process of selecting the most relevant features from a dataset to improve machine learning model performance. Final summary. Feature selection is an important machine learning technique used to identify the most useful input variables. By removing irrelevant or redundant features, feature selection improves model accuracy, reduces overfitting, and speeds up training. Techniques such as filter methods, wrapper methods, and embedded methods allow machine learning systems to focus on the most informative features. Understanding feature selection is essential for building efficient, interpretable, and high-performing machine learning models.